Welcome to EDU World Space.
Problem 3.108. In this problem, we have to calculate resultant equivalent force because of these four forces acting on the system and line of intersection of the resultant force with the edges of the plates that is given in this problem, that is ABCD. So ABCDEF. Alright. So first of all, we will calculate the resultant force that is acting on the system. So we can observe here that BCDE is a square. So its diagonal is going to make an angle 45 degree with its side. So this angle will be 45 degree. So this angle will also be 45 degree. So if you drop a perpendicular from line B to line EC, so this is, let's say, M. So this length of BM will be, since this height is 6, this angle is 45 degree. So BM going to be 6 cos 45 degree. So we can write the value of BM as 6 cos 45. Alright. Apart from that, we have to first calculate the value of resultant equivalent force that is acting on the system. So we can see here that this 50 pound force and the another 50 pound force are anti-parallel to each other. It means that their force vectors are going to cancel out each other's component because they have 180 degree phase angle. So they will cancel out each other. So the only forces present here will be 40 pound and 20 pound that will contribute in the equivalent force calculation. I'm considering here this direction to be x-axis and the vertical direction to be y-axis. So we can write the resultant force R as this 40 is in negative x-axis. So this will be minus 40 I cap and this 20 will have plus 20 j cap. So if we calculate the magnitude of this resultant vector, this will be under root of minus 40 whole square plus 20 whole square. And this comes out to be 44.721 pound. 44.721 pound. Now if we talk about the direction, since this will be in third quadrant, alright, so we can write it as our resultant force is 44.721, which is making an angle. Let's say this angle is theta. So theta will be, alright, this will be in second quadrant since J component is positive and I component is negative. So this angle will be theta and theta will be tan inverse J component divided by I component, that is 40, and this comes out to be 26.565 degree. Alright, so this is the answer for the first part, in which they were asking the magnitude of the resultant force and the direction of the resultant force. Now in second part, they are asking the point of intersection on this plate. So let us consider that here let us say that this was the equivalent diagram in which resultant force is acting on the side AC. So if we draw this vector, resultant vector, as I component is in negative x direction and this component is 40 and the vertical component is 20 pound, this is 40 pound. So we can let us say that this is at a distance B from the side C. So we can calculate the value of moment about point C in both the problem. And why this I am choosing here the point to be C, because these two force line will pass through the point C. So moment because of these two forces will be 0 about the point C. So in actual diagram the only moment about point C will be because of this force couple. So if we calculate moment about point C in actual diagram, it is going to be 50 force multiplied by perpendicular distance, and perpendicular distance here is bm, and that is 6 cos 45. So this will be 50 multiplied by 6 cos 45. Now if we consider about the direction, so this is going to cause a clockwise couple, so this will be negative. So this must be equal to the moment caused by these resultant forces about the point C. So if we observe, this 40 pound force will pass through the point C, so moment because of this 40 pound will be 0. So the only moment will be because of this 20 pound force, and that is going to cause a clockwise couple. So I will use here negative sign, and 20 multiplied by its perpendicular distance, that is D. So by solving this, D comes out to be 1 point. So D comes out to be, we can solve this, .607. So this is 10.607 meter. So in the problem, actually they are asking this distance. Okay, they have not provided the reference point, so we can write it from any point. So in this problem, we have the distance D 10.607 meter from the point C along the line AC in the left direction. Now for the second line of action, so we can observe that this force vector will be in this coordinate. So its another line of action can be along the line, along the side DE, or along the side FD. So its line of action can cut this side or can cut this side. So for that, first of all, let us consider that this is going to cut on the line CD. So if we consider this scenario, so we can draw again the equivalent diagram. In that case, if it is cutting the line along the line CD, so we can draw here our equivalent force, and that is 20 pound in vertical axis and 40 pound in negative x-axis. And again we can calculate the value of moment about point C. So value of moment about point C in actual diagram, that was minus 50 multiplied by 6 cos 45, and in equivalent diagram, this 20 pound force is going to cause 0 moment, and let us say that this time this distance is D. So this will be, again this is going to cause a clockwise couple, so I will use minus 40 multiplied by D. So we can get the value of D here. So D comes out to be 5.303 meter. Now length of this side is 6 meter, okay, and 6 inches, and I have done mistakes here also, in the unit of the distance, and this distance is inches. Again here also the distance unit is inch. So this side is of 6 inch, and this distance comes out to be less than 6 inch. So our assumption that the line of action is of this resultant force is going to cut the line CD is true. So it is going to cut at a distance 10.607 inch in the left of C, and at a distance 5.303 inch downward from the point C.